And welcome, students. As we get into our first of two lessons on generics, let's just jump into some generics basics. So, recall we've talked about type parameters. Classes and methods can have a type parameter. The type parameter may then have any reference type and hence any class type plugged in for the type parameter. Now, this plugging in produces a specific class type or method. So, for example, the code to the right shows a very simple class definition with a type parameter t. So, public class sample t, private t data, public void set t, new data, data new equals new data, public t get data, return data. Now, you may use technically any non-keyword identifier for the type parameter. You don't have to use t. Like, it could be fish, for example. Perfectly fine. But why are we using t? Well, it's just kind of a convention. Type parameters start with an uppercase letter. And there's some tradition of using a single letter for a type parameter. So it could be t, it could be c. Well, often why it's t is because, well, t for type parameter. Starting with the uppercase letter makes sense because typically a class type is plugged in for the type parameter. And class names, you remember, often are uppercase. Now, a class definition with a type parameter is stored in a file and compiled pretty much just like any other class. So there's not really anything special about how it gets handled. It's just pretty much another class as far as the compiler is concerned. So, for example, the parameterized class shown on the previous slide would be stored in a file named sample.java. Once the parameterized class is compiled, it can be used just like any other class, except that when it's using your code, you must specify a class type to be plugged in for the type parameter. So, for example, the class sample from before could be used as follows. We have sample string, object 1 equals new sample string, object 1.set data hello, system.out.println, object 1.get data, sample pet, object 2 equals new sample pet, pet p equals new pet, then some code to set the data for object p, then object 2.set data p. The class pet, in this case, if you remember, we did this all the way back in programming 1. We did a pet class. But ultimately, the details of what pet is doesn't really matter. All right? It could be any class. It could be the person class. It could be the Android person class that we did. It doesn't matter. It's just a class, in this case, that's creating that object. Now, this leads into something called instantiate or instantiation. That's a mouthful. I don't know if I can pronounce it correctly. A class such as sample string that you obtain from a generic class by plugging in a type for the type parameter is said then to instantiate the generic class. So we could say sample string instantiates the generic class sample. Now notice the angular bracket notation for the type parameter and for the class type that is plugged in for the type parameter. We've seen this notation before with array lists. All right. So type inference has something that came around with Java version 7. It's a feature. All right. And with that feature, Java can infer the base type in the call to the constructor based upon the base type used in the variable declaration. That is, let's look at the following. Class name, base type, object name equals new class base type can also be written as class name, base type, object name equals new class name. Now, obviously, the new format is going to save us a little bit of typing, and it's also a little bit cleaner to read. It doesn't have quite as much code standing in front of us. However, the reason why you'll see this first one a lot more is because programmers have been using the earlier format for quite some time. So you're more likely to see it in existing code. And for greater compatibility, a lot of the examples in this course do not necessarily use the new syntax because a lot of times you might come across legacy code that's still using the older syntax. And of course, as I mentioned, we have examples like array list. So array list string equals list, new array list double, list 2 equals new array list 30. All right, here's a quick tip for you. Compile with the excellent option. There are many pitfalls that you can encounter when using type parameters. If you compile with the excellent option, though, you'll receive a lot more informative diagnostics of any problems or potential problems within your code. So, for example, the class sample should be compiled as follows: Java C-excellent sample.java. Now, since we're using an IDE to compile our programs, aka Eclipse, we should always check the documentation to see how the compiler will set those options. Now, when compiling with the excellent option, you'll get more warnings than you would otherwise normally get within your code. And remember, a warning is not an error. And if the compiler only gives warnings and no error messages, well, then your class is compiled and can be used. However, in most cases, be sure that you know exactly what that warning is trying to tell you. All right, if it's just like, oh, this variable is not used, well, that's not a big deal. All right, but there are certain times when you should look at the warnings and make sure that it's not something that you may have missed within your code. All right, make sure you're confident that it doesn't really indicate an underlying problem in your code, or else you'll have to change your code in order to eliminate that warning. One warning that might get on some programs in the text is no definition of serial version UID. Now, discussion of like this particular warning, for example, is beyond the scope of the course. So for our purposes, we're going to safely ignore that warning if it appears. All right, so here's a quick example. A generic class for ordered pairs. In the generic pair demo, we have given a parameterized class for ordered pairs of values. Now, you'll notice that the constructor heading does not include the type parameter t. So if I come over here to pair, of course you can see we have public pair. There's no parameterized here. Now, of course, down here we do have ones for these. This might seem counter to your intuition, but that's simply just the way that gets done. The constructor can use a type parameter such as t as the type for parameter for the construction, or for the constructor, excuse me, but the constructor heading does not include the type parameter in angular brackets such as t. And we can see that clear as day right here. Now, by using this parameterized class with the type string plugged in parameter t as shown next, you can get a class whose objects are pairs of string values. So pair string, secret pair equals new pair string, happy day. All right, and we can see in the generic pair demo, we have our, right here, happy day. Here's our pair. Now, by using this parameterized class with a type integer plugged in for the type parameter t as shown next, you could get a class whose objects are a pair of integer objects. Pair integer roll of dice equals new pair integer, new integer 2, new integer 3. Now, if pet is some class you define, you can plug pet in for the type parameter t as shown next to get a class whose objects are a pair of objects of type pet. Pet male equals new pet, pet female equals new pet. Some code to set the data. Pair pet, breeding pair equals new pair, pet female comma male, or male comma female. All right, so before I move on to the pitfalls here, let's just go ahead and take a quick run here at the generic pair demo. All right, enter 2 words. All right, I'm going to put computer and science. All right, it says you guessed incorrectly. You guessed computer, and then science. The secret words are happy day. So all it does in this case is just checking to see if it's a secret pair of words. All right, so what about our pitfalls? And there's quite a few to talk about today. So a generic constructor name has no type parameter. So the class name in a parameterized class definition has a parameter attached, such as pair t, within the generic pair demo. So if I go back to pair, you can see there's our pair t. This can mislead you in thinking you need to use the type parameter in the heading of the constructor definition, but you do not need to repeat the type parameter specification in the heading of the constructor definition. So for example, we'll use public pair. Do not use public pair t. And of course, that's right here. Public pair. Boom. Now, constructor can use the type parameter says t as the type for a parameter for the constructor as the following, but the constructor heading does not include the type parameter angular brackets such as t. Public pair t first item, t second item. All right, and that's of course this constructor right here. Sometimes it might seem that people might say like, think of ways to make programming more confusing. Which, you might be like, wait, what? Some things are counterintuitive. Like, why does this work this way? Why am I looking at my code screaming angrily? Well, as we just noted, in the definition of parameterized class, a constructor has no type parameter in angular brackets. And it's like, wait, what about those angular brackets? I thought those were important. Well, if you see the following, public pair, t first item, t second item. But if we look in the demo, when you instantiate a generic class by specifying a type for the type of parameter, You do specify the type in angular brackets when writing the constructor name as in the following from the demo. Pair string, secret pair equals new pair string, happy day. So where those brackets come in will be right here instead of in the constructor. However, this second case is not necessarily hard to remember. If you leave out the string part, well, Java doesn't necessarily know which pair class you meant. And additionally, if you leave out the string, the compiler would not tell you if you meant pair string, pair double, or some other pair class. So that's part of the reason why we have to put it there within the demo code. All right, here's another pitfall. You cannot plug a parameter type in for a type parameter. You probably have already figured this one out. The type plugged in for a type parameter must be a reference type. All right, can't be a parameter type says int, double, or char. We kind of talked about this when we talked about like array lists. However, now that Java has things such as automatic boxing, this is not as big of a restriction because, of course, we can use things such as the wrapper classes. So if we want a pair int, well, we can't do that, but we can do pair integer, and thanks to automatic boxing, we can use pair integer with int values. All right, which, of course, we can look at real quick here in generic pair demo 2. I'll look at that in just a minute with you. But first, the most typical type to plug in for a type parameter is not going to be a wrapper or anything like that. It's going to be a class type. However, you can technically plug in any reference type. Therefore, you can plug in an array type for a type parameter. All right, additionally, a type parameter cannot be used everywhere a type name can be used. Within the definition of a parameterized class definition, there are places where an ordinary class name would be allowed, but a type parameter is not allowed. You cannot use the type parameter in simple expressions using new, so the keyword new, to create a new object. For example, the following are all illegal in the definition of a parameterized class definition from type parameter t. T object equals new t. Can't do the new t part. The t object part's fine, but the new t is not. T array A equals new t10. Well, the t part, first on the left-hand side, perfectly fine. Right-hand side, not so much. This restriction is not necessarily as arbitrary as it might appear. In the first case, t is not being used as a type name, it is being used as a constructor name. In the second case, t is being used as something like a constructor, although it is not officially a constructor. All right, here's another pitfall. An instantiation, if I can say that word, Lord help us all, right? Of a generic class cannot be an array base type. I really struggle with this word here. I don't know why. But that being said, arrays such as the following are illegal. Pair string array A equals new pair string 10. It's illegal. Can't do that. Not going to happen. Well, this is a reasonable thing to want to do, but it's not allowed because of technical details having to do with how Java actually will implement generic classes. And the reasoning for that and the full explanation is beyond what we're going to get into in this course. All right, now enough pitfalls. Let's talk about a tip that you can do, which is that a class definition can have more than one type parameter. All right, so this is going to lead us into the next thing, but a generic class definition can have any number of type parameters. The multiple type parameters are listed in angular brackets just as in the single type parameter case, but are separated by commas. For example, we've rewritten the class pair so the first and second item of a pair can be different types, and in the two-type pair demo, we give a simple example of using our generic class with two type parameters. All right, so before I flip on to the next slide, here, of course, is generic demo 2, all right, which you can see is the integers wrapper class. So if I run that one, enter two numbers, let's do 5 and 6. We get incorrectly, so your numbers are 42 and 24. So if we want to look at the two-type pair, remember that a generic class cannot be an exception class. If you begin an exception class definition as follows, you will get a compile error message. Public class, my exception, T extends exception. It is still illegal if you replace exception with error, throwable, or any other descendant of throwable. You cannot create a generic class whose objects are throwable. That's kind of one of those big pitfalls here of generics. All right, bounds for parameter types. I know this is a lot of slides. We just keep going. Bounds for parameter types. Sometimes it does not make sense to plug in just any reference type for the type parameter in a generic class definition. So, for example, consider the generic class pair. So, as we want to add a method that returns the maximum of two elements in an ordered pair. We could just add the following method definition to the class, public T max If first dot compared to second is less than or equal to 0, return first, otherwise return second. Well, recall that the method compare to is required to be a member of any class that implements the comparable interface. The comparable interface is a standard Java interface that was discussed back in Programming 2. Recall that the comparable interface has only the following method heading that must be implemented: public int compare to, object other. When defining a class that implements the comparable interface, the programmer is expected to define compare to so that it will return one of three things: a negative number if the calling object comes before, a 0 that equals the parameter, and a positive if the calling object comes after the parameter. Well, this works great, except for pretty much one really kind of big problem. This only makes sense if the type plugged in for the type parameter t satisfies the comparable interface, but Java allows you to plug in any type for the type parameter t. Now, you can have Java enforce a restriction on the possible types that can be plugged in for t. To ensure that only classes that implement comparable interface are plugged in for t, begin your class definition as follows: public class t extends comparable. The part extends comparable is called a bound on the type parameter t. Now, if you attempt to plug in a type for t that does not actually implement the comparable interface, you're going to get a compiler error message. Now, note, you're going to, in this case, use the keyword extends, not the keyword implements, as you might naturally expect, because it's an extension of the comparable class in this case. Talking about bounds again, note that the bound extends comparable is not just an optional, nice little thing. If you omit the bounding, you're going to get an error message from the compiler saying it does not know about the method compare to. A bound on a type can be a class name, or rather an interface name, in which the case only descendant classes of the bounding class may be plugged in for the type parameters. So, for example, the following says that only descendant classes of the class employee may be plugged in for t, where employee is some class. Public class, same generic class, t extends employee. Now, of course, you can also have multiple bounds. You can have multiple restrictions upon your code. This explains why the keyword extends is used in bounds rather than implements. You can have multiple interface and possibly one class in a bounds expression. All you need to do is just separate the entries with the ampersand, as in the following example: public class, another generic class, t extends employee, and comparable. If you have more than one type parameter, the syntax follows the following example: public class, yet another generic, t1 extends employee and comparable, comma, t2 extends comparable. You can list any number of interfaces in a bounds expression, but you may only list one class in a bounds expression. Moreover, if you do list a class in some interfaces, the class must be first in the list. That's why it's the public class, and then it goes on with the other stuff. All right, another quick tip for you is that of generic interfaces. An interface, of course, can have one or more type parameters. The details and notation are the same as they are for classes with type parameters. All right, and that's it on the notes part. Let's just go ahead and look at some quick demo here. So I kind of held these off here, but here's the to pair. All right, so to type pair. And if we look at the demo of that, you can see this is very similar to what we've done before. We have a string and an integer. So when we run that one, how would you rate them? Let's give them a 6. Okay, our new rating is a 6. Perfect. All right, and we look at pair comparable. You can see that this is simply just an extension, just as we kind of mentioned in the code. So make sure you use extends and not implements. All right, and that's going to wrap up everything, folks. It's kind of a longer lesson than we might be used to, but we're flying through generics. We have one more lesson on it, and then we will be wrapping up this chapter pretty quickly. The next chapter is going to be a lot longer. We're going to spend a lot more time on it because data structures that we're going to be talking about are going to be very important for anyone that's really serious about a Java career. So with that being said, I will see you next time.